I hope I'm audible to everyone. Very good afternoon. Pratima, very good afternoon. Sharan Niti, very good afternoon. I hope I'm audible to everyone. My voice is very clear. So please give your reply in chat box right now. Yes, Krishna Mokan, very good afternoon. Asha Naveen, very good afternoon. Yes, thank you so much for the good reply. And Ravi, very good afternoon. Krishna Mokan, good afternoon. And Kamaljit, right? So Kamaljit Singh, thank you, very good afternoon. And I hope I'm audible. Dr. Batmavati Telkar, very good afternoon. And Raghava Palavali, very good afternoon. Ashwini, good afternoon. Deepamala Singh, very good afternoon. Makesh Singh, very good afternoon. And Prapachit, good afternoon. And thank you so much for the good reply, Mr. Sharaniti. And yes, so without delay, I'm going to discussing with you that next project in machine learning technology. This is completely regression based problem statement. So medical insurance means today I have for collecting this particular data. Today I'm going to use it. That is actually like that insurance data. Today I'm going to use it. Okay, so you can see this one: age, sex, BMI, children, smoker, region, and charges. So based on this particular criteria only, what are the charges? What is the charges that is actually like that? Based on this particular target only, the amount is actually like that comes under like this. So this is the independent data. Sorry, this is the dependent data. This is the independent data. So age, sex, BMI, children, smoker, region, and based on this particular data features only, so we can get it this particular data. So today I'm going to discussing with you, and today I'm going to training my model with the help of these particular data. Today we are going to entering that visualization part also, that is we can call it as the ETA process as well. Okay, right. So what is the medical insurance? You must have heard some advertisement regarding the medical insurance that promises to help the financially in case of any medical emergency. Correct? Yes, that is what we are going to like use that medical insurance or healthcare insurance. Various will be like it depends on the various of the factor. Based on the age, based on the BMI, range will be varied. When it is comes to kind of the problem statement, we can use the machine learning method that will be help to predict the cost of the medical insurance, of course. So for that, we are going to train a model for this particular category: age, sex, and also the BMI. Based on this particular criteria, the amount of the particular like the terms based on the feature that it can be possible to give that prediction as well. So what is the objective? We will be try to extract some insights from the data set that will contain the detail about the background of the person who is perceiving or data that will contain the details of backgrounds of the person who is purchasing the medical insurance along with what amount of the premium is charged. So based on the features only, we can predict the amount of the premium amount. Okay, that is the objective. We are going to train a model and we are going to creating the model. What are the project actions today we have to follow? The first one, collecting the data and data pre-processing, and the data pre-processing in this, and we need to check the null values of this particular each and every column. If it is, the data is actually very clean, no need to pre-processing of this particular things. So already we guys knows about it, the pre-processing method. The pre-processing is actually like the objective of making the clean the data and also the making the properizing data for the model training. Once it is done, what is the next procedure? We are going to splitting the data for the testing and also the training. That will be more helpful for creating the training data as well as the testing data. So collection of the data, pre-processing has done. After that, we are going to entering the splitting the data for the testing and also the training that will be help to creating the training data as well as the testing data. Once you create it, after that we need to choose the right algorithm of the model. So basically the regression problem in the sense automatically the linear regression comes in your mind. Because of that will be giving the good solution for this particular model and for this particular problem as well. When I am going to entering the linear regression model and linear regression algorithm, that will be giving the good solution for the regression problem or numerical value. So with the help of that particular model, when we can train our model. Once you train that particular model, we are going to feeding the new data to the trained model, that is called the linear regression trained model, that will be giving the price of the prediction of the medical cost insurance. Of course, it can be possible. This is the procedure. So based on this particular procedures only, we are going to write a code one by one. Already we guys knows about it, that particular procedure. Data collection, pre-processing, splitting the data for the testing and also the training. Once the training data and also the testing data has created, we should entering into the model creation and also the model training. Once the model has trained, we should entering the new data to the trained model. That particular trained model will giving the prediction, that is called the price of this particular medical insurance. Once it is done, we should understanding the linear regression model. What is the linear regression model? It is a supervised machine learning algorithm that will be solving the solution of the regression problem, and it is also the statistical method that is used for the predictive analysis. So most probably the output will be comes under the numerical value or continuous numerical value. And also, that logistic regression makes the prediction for the continuous and also the real numerical values. For example, such as salary prediction, age prediction, price prediction, sales prediction. All the values, all the problem statement output will be comes under what? Numerical, continuous numerical. Here you can medical okay. Once you're collecting this particular data, just to open this particular data for the better understanding, you can see this one. The same data set is here. That means age, sex, BMI, smoker, region, and also the children, and also the charges. So this is actually like one kind of the data. Okay, you can collect it from the Kaggle. That is the procedure to collecting the data. Okay, that is the procedure to collecting the data from this one. So right now, I will be moved to the Google Collaborate notebook. I uploaded this particular data. This is actually like the insurance.csv. This name is actually, I gave the rename of this particular things. How we can rename of this one? Just rename the file and make as your comfortability. Okay. Once you are uploading this particular data, first of all, what should we need to do? Import the necessary library. When you are going to entering the machine learning technology, what is the major important library? ASPD. Correct? Huh? So ASPD, and also the NumPy also needed. Matplotlib is actually that needed. So before that, import NumPy as NP is needed. Then import matplotlib matplotlib.pyplot. Then import train test split. Import people as PLT. Then import Seaborn as SNS. Then once it is going to be run, this one the libraries has executed. What is the next procedure? Data collection and upload, right? Data collection and analysis. So that process is going to be done. So here data is equal to, so I have created the variable like that insurance data or data. So just I have create the variable name as our comfortability. So I have created a variable name as actually data. Then pd.readcsv is the function, and you can pass that particular data here. So I hope you guys are watching me. If you guys are watching me in the sense, please mention in the chat box and please be engaged with me, because of you guys are very less interaction. So that is not right. So please be interactive more. Then only the session will be completely interesting. then only the session will be completely interesting. So please keep your interaction with me. That is the most important things. I hope you guys are watching me. I hope you guys are watching me very effectively, right? If you guys are watching me in the sense, please give your good reply. Okay, please give your good reply in a chat box right now. So once it is done, we can make that insurance.csv be loaded. Okay. So what is the next procedure? We need to ensure whether it is a data is actually loaded or not. So .data function will help to ensuring your data with displays the first 5 rows of this particular data. That you can see this one, first 5 rows of this particular data. That is age, sex, BMI, children, smoker, south regions, and also the charges. Okay, charges. So this is the data we uploaded. Now we are going to analysis the data. So analysis the data means data dot shape. So data dot shape means it is going to be displays the rows and also the column. Totally 1338 rows and 7 columns. That you can see this one 1, 2, 3, 4, 5, 6, 7. And entries is actually rows 1, 3, 3, 8. After that I am going to display the information of this particular data. So info of. So the info of will help to display the information of this particular data. Totally the entries is actually 1338. So we'll check the non-null. So 1338. That means there is no null value. The data is actually very clean. Correct? So it is start from 0 to 337. And also the columns name, age, sex, BMI, children, smoker, and also the regions, so charges like that. And this is the data type of this particular each and every column. Once you've done this one, what is the next procedure? What is the next procedure? We should check. So before that, I will tell you one thing. Region, smoker, and sex. This will be actually the categorical data, correct? So categorical is sex, comma, smoker, comma, region. So this is actually like the categorical columns that I will be explained one by one. So now we are going to check the missing values. So how we can check? Data dot is null of dot sum of, that will be help to displays the null values of each and every column. It displays the all the values is actually 0. That means each and every column is actually very clean column. There is no null value in this particular data. Correct? Correct, guys? Yes, I hope you guys are watching, but I got a reply only 2 or 3 personalities. It's okay, fine, but we have to give your reply in very effectively. Okay. Right now, we are going to entering that statistical measurements of this particular data. What is the statistical measurement? Dot describe. So that will be help to display the standard deviation of each and every column, mean value of each and every column, median value, mean value, minimum value, maximum value of each and every column. That values is actually in a numerical in this one, that will be going to be displayed. That you can see this one, maximum value of age, maximum value of BMI, that maximum count of this children is actually 2, and the maximum charges is actually 16,000, and mid value and median value. So based on this particular like that mid value and also the mean value, so there will be like that similarity. That means there is not much more difference on this. This is actually good distribution of this data. Normal distribution. We are going to comparing the mean value and also the median value. If the data values is actually very equal to the all the values of this particular column, that means the data is actually near to that. Now we are going to enter the ETA process. So that is EDA visualization. First, distribution of the age, we can find it. So distribution distribution of age. Here you can run this, call the SNS.set of. Then I'm going to size the figure size from the matplotlib. So I'm going to defining the figure size as per our requirement. So here fig size is equal to 6 comma 6. So what is the meaning of this one in this one? This will be help to creating the Canva for the visualization. So dot figure will help to creating the Canva for the visualization. That is a user defined size. Here you can change the value as per your requirement. And after that call the SNS. So SNS having the distribution plotting. So dist plot and of you can pass the data of for the age, okay, for the age, then PLD dot title of age distribution. Okay, then after that PLD dot show will help to show the graphical representation. Once I'm going to run this one, and you can see the graphical representation of this particular things, and it is going to be like the distribution. You can see this one. This is actually like that normally distributed, not right side skew, not left side skew. It is actually eventually distributed. It is actually eventually distributed. The age range is actually like a little bit near to that. You can see. Understood? No? So here you can see this one. This is called the normally distributed of this particular data. Now we are going to enter that value counts of the male and female. So how we can check the value counts? Data of gender or sex. So here the sex is actually like in the columns. Dot value counts and run this one. You can see the count of male and also the female. Right now I will be like going to display the count plotting. So first initially PLD dot figure size dot figure of here you can see the fig size is equal to 6 comma 6. I am going to defining it. This particular 6 by 6. After that you can use the SNS dot count plot. So SNS means seaborn. So count plot of here you can pass this x is equal to 6. Okay. Then data is equal to data. Here whole data set you can pass it. Then after that PLD dot title of sex distribution. Sex distribution means count. So distribution. Then after that PLD dot show of you can see the output of this particular thing. So PLD dot show and the title, and you can see this one nearly similar to the count of this one, that you can see this 676 662. That's it, very similar, very similar of female and also the male counts of this one. Sex distribution, this is based on this particular title, and you can see the count and also the female as well. And right now this is called the what should I say, this is called exploration of this particular data, correct? So right now I will be moved to the next things is actually like that BMI distribution. So for this actually like that the same way PLD dot figure size I'm going to defining it. So the same thing I'm going to follow. So for that I'm going to like that use the same format for the distribution. So yes, so here the figure size, and here I am going to use it the distribution plotting. So dist plot of here is actually remove the sex, because of the only one column we have to pass here, and of here is actually like that BMI is the column. So here is actually like the BMI distribution. So BMI distribution, that is a change, and you can see this one. This will be is also like that normally distributed. Dot is not much skew data. This is not much skew data, but you can see this one, this particular distribution of this one. this distribution is actually very normal and normally distributed like this, decreasing and also the increasing. And this particular BMI is actually like that this is sometimes the data is going to be distributed like that, and this and that is the right side skew. If the data is going to be this side and this and that is the left side skew. This is actually like that very normalized data. So you can, if the null values is presenting in this particular column, you can use the any central density value, that means mean, median and also the mode, anything. And after that we are going to entering that children count. Okay, children count. So what is the children count? We can see this one with the help of the so here I am going to use the children. When I am going to see this particular things is actually like that the children's count is actually different category. So for this, right now we can see the count of this particular category 0, 1, 2, 3, 4, 5, and this is the count of the each categories of the children. Each categories of the children's, that you can see this one. This is also kind of exploration of this particular data. When you are going to see this particular data, it will be more exploring of this particular things. So I will be make it as a 4x4. Yeah, you can see this one. This is actually like a good graphical representation for better understanding of this one. Correct? Correct, no? So this is for the exploring your data. After that we are going to entering that children's value counts of the count, that you can see this one. This is actually the count. So here you can see this one, the count value. Counts of, right now you can see the count for each category 0, 1, 2, 3, 4, 5. This is the graphical representation of this particular values. This is a graphical representation of this particular values. I hope you guys are watching me. If you guys are watching me in this sense, please mention in the chat box yes, because of that is the most important things to continue this particular session very effective and also the interaction way. So please be interactive more. Okay. So this is called the exploration one by one of this particular data. And one more time, that smoker yes or no. So the smoker count will be like, for an example, data dot of smoker. Okay, smoker dot value counts. You can see the value counts of this particular distributions. Smoker count is actually yes or no is actually 1064 and yes is actually 276. When I am going to using the distribution of the plotting, it will be like that increasing and also the decreasing of yes or no, and also the region counts. So data of region, so that is also the category, right? So for categorical data only you can find it the value counts. And you can see the count of this particular each category. Almost similar. Why? Because of west, south, northwest and northeast, the value is actually similar and little more very high in the southeast. Okay, right. So now I will be move to the of this particular data. So how we can use this particular the distribution plotting of the charges, because of that is the continuous value. So how we can see this particular distribution plotting of charges. Why? Because of that is the continuous value. We should know how the data is going to be distributed. That is the most important thing. So here charges, okay, charges and charges distribution. Okay, right now I'm going to enter and run this one, and you can see the distribution of this particular data. See here, this distribution is not a normal distribution, correct? This distribution is actually a right side skew of this particular data. Try to understand, when the data distribution of the right side in the set, that is the right side skew of the data, it is a positive skew. When the data is similar, so just the opposite to that, in the sense it is a negative skew, negative side of the the skew data. So there will be the differentiation, if the right side skew of the data, you can if the misvalues is missing, you can fill with the median. If it is left side skew, you can fill with the mean. If it is normally distributed, you can fill mean, median, or mode, anything. So this is the way you can find the distribution of this particular charges as well, based on the criteria. Then now I will be moved to encoding of this pre-processing methods. Okay, so encoding process we need to do. So what is the encoding process? What is the encoding process? We have the three different columns, no? We have the three different columns. So here data dot columns. So we have the three different column. This particular three different column, you have to make the value change, male into female, female into, like that. So for this, data dot replace is the one of the function. So replace will help to replacing your values. Here I am going to use the dictionary for the 6. Okay, for the 6, that is actually the most important. 6. For this particular key, you can create another dictionary. So here inside the dictionary we have the male, and for this particular male, value is actually 1. For the female is actually 0. So how we can write it actually? How we can write it? You can see this one. Data dot here the 6, then dot value counts of. Now we can see this. So male for 1, female for 0. So what is the meaning of this one? In this one, we are going to change the male 0 and also the 1 in the original data. So for this, I am going to use the in place true. This in place true will help to replace the value in the original data which you uploaded before. The same thing, you are going to check it right now. The male will be changed into 1 and female will be changed into 0. Right now we can see the changes of this. And after that, I am going to use it. Next thing is a smoker. So for this particular smoker, what is the value counts of the smoker? So already we checked, right? So for this, yes, I'm going to run it, and you can see the count of this yes or no. This particular yes or no we will be need to change, correct? So for this, data dot replace dot of, here you can creating the dictionary inside the dictionary, that we can call it as the concept of the nested dictionary. I hope you guys are watching me. If you really understanding, or if you have any queries, you can ask me right now. So here you can use the smoker column. For this particular smoker column, we have the two different value. One is actually no for 0, yes for 1. Okay, yes for 1. After that, in place true is most important to replacing the original data. So once it is done, now you can see the changes of this particular data. 0 and also the 1, correct? So 0 and also the 1, now it is going to be changed. Okay, right. After that, data dot next. What is the next? Smoker and region. So we'll see the region counter. See the region counts, and you can see that 4 different types. So I will be change one by one. 0, 1, 2, 3. Okay, 0, 1, 2, 3. The same thing, data dot replace, and going to creating the dictionary. The first one is actually region. and for this particular region we have the another dictionary, that is actually first, sorry, control Z, and here I'm going to use it, this name, just copy and paste it here, then east 0, then comma, next southwest is actually 1. So for this actually like that I can paste, and here we can paste like that 1. Come on, next south, northwest and northeast. So northwest, and I can paste it here. Then here we can call it as we are going to pre-processing the data, correct? So number 2, then we are doing that pre-processing. So hope you guys are understanding about this, for making the properizing data for the computer understandable format. Okay, right. So after that, number 2 or 3. So 0, 1, 2, 3, we make it all the things, and here you can use the in place true will help to replace the original data which you uploaded here, which you loaded here. So once it is done, we'll check it, and the same thing of this particular, you can see this one, the count is actually will be changed to 0, 1, 2 like that, right? Clear? So now we can check the data.header function. You can see this first 5 rows of this particular data. Now the data is actually very clean. All the data is actually in an integer and also the float. There is no object. There is no object. Now what is the next step, guys? Now what is the next step? Splitting the data, correct? No? Splitting the data. So splitting the data for the testing and also the training. So X is equal to, what all the data is actually needed? So these data is actually needed for us, no? Without charges is actually our input data. So X, here X, you are going to store only the input data. So for this data of, here I can pass this particular column is actually like in the BMI. Okay, so BMI and all the things. Okay, so BMI, comma, and this is actually like that one kind of the method. So this is actually that particular data. So here I can make this and comma. Right now, I have stored to the X of these particular age, sex, BMI, and also the children, smoker, and region without a charger. Why? Because of the charges is actually Y data. The charger is actually Y data. Here I am going to run this one. Run this one. It has to store maybe that. Okay. So I made some mistake here. Otherwise, we'll see this one. Okay. We'll check it with the help of this particular format. Maybe this will be done, or it is not good means we can go with, yeah, this is data frame is actually not callable, correct? So for this, I will try the another method. Okay. Okay, fine. So data dot drop is the method. So what I'm going to do it here, I don't need that X, okay, only the charges. So for that the columns is equal to charges I don't need. Charges I don't need. Then here I'm going to access is equal to That's it. So once I have done, okay, once I have done, the X is actually done. Then what about Y? What about Y? Only that charges. Only that particular charges. That's it. Correct, huh? Only that particular charges. Right. So now I'm going to run this one. So what is the meaning of this one, guys? What is the meaning of this one? I have stored input data to the X. I have stored output data to the Y. So input data means without charges. Output data means only charges. Understand? So right now you can see the data like head of. So without charges, this will be input feature, and only charges, this is actually output feature. That you can see this one, that is dot head of. Okay, so here you can see this one, this is actually like the output data. Okay, input feature, based on the input, the output will become like this. Okay, so next, what is the procedure? What is the procedure? Guys, what is the procedure? Any idea? Okay, so now I will be creating the training data and also the testing data from sklearn dot model selection. So for creating the training data and also the testing data, we need train test split function. Train test split is the function that will be help to creating the training data. So I'm going to make it faster because of now the time is actually 3:40. So very fast away. So now I'm going to creating the training data and also the testing data. So xtrain xtest. Okay. So input data for training and also the testing. Output data for training and also the testing. This is the format. Don't change the format, otherwise the value will be going to be changed in a different position. So for that, the same format you have to utilize to creating the training data and also the testing data. So train test split of pass the X input, Y output. Then we needed 4 different parameter. That is actually test size is equal to 0.2. Okay. Then I am going to use it this random state. So what is the meaning of the random state in this sense? It will be help to not change the accuracy score when you're going to run in a multiple time. When you're going to run in a multiple time, the random state value will be 0 to 42. As per the article, they mentioned 0 and also the 42 gives the good accuracy score and also the fixed accuracy score. For that, I am going to deciding 42 here. So usually I am going to prefer 0 or 42. Okay. So X is the input, Y is the output. Testing size 0.2. That means testing data 20%, training data 80%. So 80% means when you are going to training your model, that should be very high than testing data. That should be very high than testing data. Now, once you're creating this one, you can see the shape of this particular data. You can see the shape of this particular data, xtrain.shape and xtest.shape. And you can see this one. What is the meaning of this one in this one? 80% and also the 20%. That's it. So for the better understanding only, I am using this particular, the shape of this particular data. Once you're creating the training data and also the testing data, next procedure what? Model creation and training, correct? Okay, fine. So how we can creating the model? Here is of course a regression problem. Based on the input data, what is the output value, cost value or price value? That is the numerical value, correct? That we can call it as a regression problem. So here we are going to use the regression algorithm. How we can use that, call that particular algorithm from sklearn. Okay, we have the modules like that linear model, then input linear regression is the algorithm name. Once you importing that one, for this algorithm class you have to creating the object. So for that linear regression of, that's it, right? So once you creating that one, this is the model has created, the linear regression model has created. So after that, what should we need to do? Model dot fit. Fit is the function, correct? Here you can pass the training and also the training data. So that means training input. So model dot fit of training input, training output. So once the model has created, after that the model training has been possible. So once the model has trained in this, and this is the thing is actually what confirmation of model has trained. Once it is done, we should calculating the accuracy score. For this, why? Because of the model is trained, the process has done, but we don't know this particular model is perfect or not for the good prediction. Based on the accuracy score only, we can defining it for the best model, correct? So we need to calculate the accuracy score, that is called the evaluation process. Evaluation. So that means we are going to calculating the accuracy score. So from scale learn dot metrics, then input or square score is the function. Okay, score is the function. This particular function will help to calculate the accuracy score of the regression problem. Okay. So okay, or square score, this is the function I'm going to use it today to calculating the accuracy score. Okay, so in this particular r square score, we need to calculate the we need to pass the two different parameter. Already we guys are knows about it, predicted output, correct? Predicted. So predicted output is equal to model trained model dot predict of, we can pass the testing input. Okay, testing input. After that, what should we need to do? Calculate the r square score, correct? The score is equal to model dot predict, sorry, uh, r square score of, here you can pass this predicted output comma y test. So once you comparing this one, it will be written the 70%. Okay, it will be written the 70 percentage of the testing at r square score. Okay, so if it is like, you know, that returning only that what should I say, that 70 in the sense that much not a good model, correct? That is not a much good model. Uh, just a minute, we'll check it that. Yes. So it will returns actually like, you know, that only 70%. It will be only return the 70%. So I'm going to like, you know, that run it one more time all by one. Then only you can understand more about this. So run, 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 run. Yeah, you can see this one. It returns the 70%. So normally I told you that it is actually like that the score will be 74, 75 above this, and that will be a good model. It is not much a good model. But I will tell the procedure to creating the what should I say, predictive building system. As it will be what we can see this one. Okay, right. So first input we have to put it here. Input data is equal to off. Here you can pass the values like that. What is the data? Age 15. Just mention that. Female 0 or 1, and next BMI value that may be 45. Okay, 0.7 something, any other thing, and as a children like two children. Then next region, smoker or region, correct? Smoker is actually like that 1, yes, and another thing is actually region. So I selected like north west. Okay, north west. So here I'm going to like passing the input data. Now we need to change input as a array. Okay, so input array data is equal to numpy dot as array of was the input data. So now this array has changed. Okay, the input data has changed as an array. Okay, array. Then reshaping of the array. Re-input. Okay, otherwise we can go with the input reshape. Okay, is equal to okay this data, then paste dot reshape -1, 1. So this will be converted into the single dimension. Next we are going to enter the prediction. Okay, is equal to model dot predict. Okay, predict of, you can pass this particular reshaped data. Okay, reshaped data, then copy and paste it here. After that, print the prediction. That's it. So once it is predicted, you have to print that the insurance cost in USD prediction. Now I'm going to run this, and you can see the output of this particular things is linear regression is expecting 6. 1, 2, 3, 4, 5, 6. Correct? No? So here I can just change this -1 one more time. So here you can see this one. For this actually that medical cost will be like another 31772. This is the prediction value, and this is the prediction value. You can see this one. Otherwise we can see this one. What is the value will come for this particular 18 or this one. Okay, we'll check it now. We'll check it. Maybe good prediction or bad prediction. For this, I'm going to use it 18, and male is actually like that 1, and next value is 33.77, correct? So what is the value will come? We'll see it. Then children actually 1, then 0, 0, then southeast, correct? Southwest, southeast. So southwest, southeast actually southeast actually 0, correct? Huh? Yes. So here I have passed 0. Okay. For this, what is the value will become? Yeah, 3677. But here only 1726. It is not much big difference. Correct? Why? Because of that value is coming like this only, in the sense our prediction is actually only 70%. Somewhat the 30% is actually error. That may be not a good prediction, but we have to like that increasing to 90% of the accuracy is good, then only it can be predicted very correct. So this is the thing. Okay, this is the thing. This is called the medical cost insurance. Okay, medical cost insurance. Hope you guys are understanding about this one. Hope you guys are like that understanding about this particular concept. Understanding about this particular concept. If you understood very well and clear on this one in the sense, please mention in the chat box. Yes, yes, Philip. You understood about the concept, guys? It's clear? So this is all about that machine learning technology and artificial intelligence for classification. Yesterday we discussed about the classification. Today we discussed about the regression problem. Hope you guys are understanding about this supervised machine learning technology. How does it actually that work? I hope you guys are really understanding about this particular concept, I thought. Yes. Okay guys, we'll see you tomorrow with a different topic of this particular FDP program. That maybe tomorrow itself we can continue with the IOT with a different guy. And thank you so much. Thank you so much, and good night all. Have a delicious dinner. Bye bye. Have a nice day. Thank you.